everyone. So today we'll be discussing the Chinese remainder theorem. And so the Chinese remainder theorem is basically a way to solve for a unique solution based off a system of congruences. And so kind of some preconditions for the Chinese remainder theorem is within your system of congruences, you have to make sure that your mods are relatively prime to each other. That means that the greatest common factor between these numbers that are being modded by is 1. And generally in this class, it's the case that if we ask you to solve for like something, a solution using the Chinese remainder theorem, that it will be the case that these are already relatively prime. But like for future use, that's one of the conditions for using the Chinese remainder theorem. And what you're going to derive is a unique solution x. And this is a unique solution mod the multiplication of these numbers that are in the mods from your system of congruences. So you're going to have a unique x mod 5 times 7 times 9, which is equal to 315. So your solution is going to be mod 315. And so how we set up this kind of question is we will have an x is congruent to some number, which I'll fill in slowly, mod 315. And so how we are going to go fill in this solution is first, we know that x is congruent to 1 mod 5. So the first number we're going to fill in is that a, or this number 1, which if you look at the definition from the discussion, that is just like considered to be an a. And so we have 1 multiplied by a specific chunk, and that will be our first term. Then we add on this second number, so we know that x is equivalent to 2 mod 7. We're going to add on this 2 multiplied by another chunk of numbers. And finally, we're going to add on our last one, which is this 3, also multiplied by a chunk of numbers. And so how we're going to fill in this chunk now is that we know that x is equivalent to 1 mod 5. So we're going to make sure that this number, this x, when we mod it by 5, this first term is going to come out as 1 mod 5. All the other terms, we want to make sure it comes out as 0 mod 5. So then if this happens, we would know that, well, that first term, it's going to be 1 mod 5. These other two terms, since they're 0 mod 5, they disappear. So when we take x mod 5, it will be congruent to 1, satisfying that first condition there. Then we know that x is congruent to 2 mod 7. So same thing as with the 5, you want to make sure this first term comes out to be 0 mod 7, and then the second term has to come out to 2 mod 7. This is kind of where you're going to get your 2 from to satisfy the second equivalence. And then we want to make sure the third term is also 0 mod 7. Finally, for our term mod 9, we want to make sure the first two are 0 mod 9 and 0 mod 9. And then our last term here, we want to make sure that it's 3 mod 9. So then when you take this x and you mod it by 9, it's only going to leave this third term, which has to be 3. And that will make sure that all of these 3 congruences hold. And so how we ensure this is we first, as we said, we put that kind of these numbers here, 1, 2, and 3 in their respective positions. Now we have to make sure that they are 0 mod, like this first term here is going to be 0 mod 7 and 0 mod 9. The easiest way to ensure that is just to multiply this by 7 and by 9. If you multiply this term by 7 and then you multiply by 9, well, then it's for sure going to be 0 mod 7 and 0 mod 9. So similarly with the second one, to make sure it's 0 mod 5 and 0 mod 9, we're going to multiply by a 5 and a 9 here. And then with the final term here, we are going to multiply that by 5 and 7. Now we go in and we have to ensure that this term is 1 mod 5. And then this term is 2 mod 7, and this term is 3 mod 9. the easiest way to do that here then is to ensure that this piece, like this additional piece you multiply by, it's going to come out to be 1 mod 5 in this case. This additional piece is going to be 1 mod 7, so that you would have like 2 times 1, and that would give you 2 mod 7 like total. And this piece here is also 1 mod 9, which will give you 1 times 3 mod 9, which is going to be 3, satisfying the congruences. And so how we get that then is by multiplying by the inverse of the numbers from before. So here you would multiply 7 times 9 by the inverse of 7 times 9 mod 5. So 7 times 9 is equal to 63, which is equivalent to 3 mod 5. So now you want to find, basically in this question, you want to find 3 inverse mod 5. And so 3 inverse mod 5, how I like to do these is just by trial and error. You can use the Euclidean algorithm if you want, but like you have 3 times 1 is 3, 3 times 2 is 6, and 6 is equivalent to 1 mod 5. So we know that then in this case, 3 times 2 is equal to 6, which is equivalent to 1 mod 5. So we know that the inverse of 3 is going to be 2. So this number becomes 2. Next, you go through a similar process for the second one here. So we would have this is 5 times 9, and then we would want to multiply by 5 times 9 inverse. And this is, we want that inverse to be in mod 7. So we would have 5 times 9 is equal to 45, which is equivalent to 3 mod 7. And so in this case, we would be looking at for 3 inverse mod 7. And so similarly, I like using trial and error to solve these. So you would look at like 3 times 1 is 3, 3 times 2 is 6, and so on and so forth. But you would get up to 3 times 5, and that is equal to 15, which is equivalent to 1 mod 7, right? So then we would know in this case, 5 would be the inverse of 5 times 9, or 3. In this case, so this term here would become a 5. Finally, we look at our last term here. Also the same process, we would multiply this by 5 times 7 inverse, mod 9. So 5 times 7 is equal to 35, and 35 is equivalent to 8 mod 9. And so we would want to look for 8 inverse mod 9. Similarly, I like just doing these by trial and error. We would know that 8 times 8 is equal to 64, and 64 is 1 more than 63, so that would be equivalent to 1 mod 9, since 9 times 7 is 63. And so we know that 8 inverse here would actually be, so like the inverse of 5 times 7, or the inverse of 8 would just be 8. So this term becomes an 8. And so our final solution would be x is equivalent to 1 times 7 times 9 times 2 plus 2 times 5 times 9 times 5 plus 3 times 5 times 7 times 8. And this is mod 315. So for the Chinese remainder theorem, this here would be our final solution. And so hopefully this kind of teaches you how to use the Chinese remainder theorem to solve for a unique solution, kind of based on this class. And in this class, you need to solve for the inverses, but after that, once you get them in this kind of form where it's like just in terms of integers multiplied together and added together, mod some number, you don't have to simplify further. So you don't have to simplify to one single answer. And actually for Chinese remainder theorem, we generally like you to leave it in this expanded form so it's easy for us to check your work. So yeah, hopefully that helps, and good luck studying for your exams. Thank you guys.